Hello! Today we're starting to look at the next stage of studying the structure of matter, chemical bonds. But let me remind you that when we were looking at the structure of the atom, we kept emphasizing that elements generally have an incomplete outer level. And the elements are trying to complete the outer level in any way they can, either by giving up electrons or taking electrons. Except for one single group, that's group 18 or group 8, the main subgroup, the elements, called noble gases or noble gases, don't tend to complete the outer level because they have that level completed. So what path do the elements take to complete the outer level? One way is by giving and taking electrons, but there are other ways where the elements combine with each other to complete the outer level. And that's what chemical bond formation is based on. That is, the elements benefit from combining atoms with each other, ions to each other to form matter. So let us begin by pointing out, and in general, in what types of chemical bonds exist. A chemical bond can be covalent. A chemical bond can be ionic. A chemical bond can be metallic. And chemical bonds can be intermolecular. And so these bonds are also subdivided within themselves. And we're only going to look at one type of intermolecular bonding so far. Let's start with the covalent bond. Covalent bond, and I will go a little bit unusual way. We will go in order to establish when this bond is formed from specific examples. So I'll start with examples. A covalent bond can be, for example, in the hydrogen molecule H2. It could be in a molecule of hydrogen chlorine. It could be in a molecule of carbon dioxide, or in a molecule of oxygen, for example. If we ask ourselves what such a bond is formed between, it is easy to see that both hydrogen, and chlorine, carbon, oxygen are not metals. Hence the simple rule of recognition. But essentially they have to be non-metals. And then you make that connection, they're not metals. But from my examples, it's easy to see that they're not the same examples. For example, hydrogen is different from hydrogen chlorine. If only because this is a simple substance and this is a complex substance, but within itself a covalent bond is indeed subdivided, it can be respectively covalent, and it's called a nonpolar bond. And there's covalent polar. Well, if I were to ask you from these examples, what you think is a covalent nonpolar bond, I think you'd guess it's hydrogen, it's oxygen, and I'll give you some more examples. It's bromo 2, or for example, fluoro 2. It's easy to see that a covalent nonpolar bond occurs when there's only one element involved. Well, really. We'll refine this definition a little bit later, but based on the examples I've given you can see here, one particular element is always involved, that is hydrogen, oxygen, and so on. And so there's a covalent polar bond. And then by elimination it would be hydrogen. That would be carbon dioxide, and then let's add, let's say, water. It's easy to see that there's going to be different nonmetals involved, or using the concept of electronegativity, we could say elements with different electronegativities, but they have to be strictly nonmetals. Now let's take ionic bonding. Here too, let's proceed from the examples and then we'll find out between what this kind of bond. An ionic bond would be sodium chloride, calcium oxide. Or for example, it would be in, let's say, bromide of magnesium. It is easy to see that in this case, metal and accordingly a non-metal. And so this chemical bond is formed between metal and non-metal ions. But I'm going to ask you to remember it like that, because if you just remember it as different elements, you'll be confusing covalent polar ionic bonding, which you shouldn't do. They're different kinds of bonding. And here's the bond that's not difficult enough to deal with. It's a metallic bond. Why? Because that's the kind of bond formed by metals like magnesium, aluminum, zinc, and so on. In them, there is a special kind of bond. It is called a metallic bond. And finally, intermolecular bonding. Intermolecular bonding is subdivided within itself. We will devote a specific lesson to this. We'll find out what kind of intermolecular bonds there are, but the most famous one in this case is hydrogen bonding. Bond. And hydrogen bonding occurs, for example, between water molecules. It's important not to be confused here. Within the water molecule itself, the polar bond is covalent, but between water molecules, the bond will be hydrogen bonding. Or, for example, hydrogen fluoride, hydrogen oxygen. Again, within the molecule itself, the polar bond will be covalent, but between the molecules, it will be hydrogen. Or, let's say ammonia. Inside the molecule, it is covalently polar, and between the molecules, it is hydrogen. So, how do you know when it's hydrogen bonding? Hydrogen bonding occurs when there's hydrogen in a molecule. And the most electronegative element, fluorine. Hydrogen and oxygen. Hydrogen and nitrogen. I must say that hydrogen bonding is a very important bond and plays a huge role, for example, in the formation of protein molecules. DNA, RNA, and some other very important molecules. We will be talking about this type of bonding additionally. So, in order to recognize where what kind of bond is, it's enough to know the rules of recognition between which elements occurs. But I must caution you, there is not always an unambiguous answer about chemical bonding. Let me give you some specific examples where there is more than one type of bond. For example, the ammonium chloride molecule, NH4 chlorine. What kind of chemical bond is that? It would seem that all the elements in this case are not metals, and that is indeed the case, but the molecule itself is constructed in a very peculiar way. There is an ammonium ion, which has a plus charge, and a chlorine ion, which has a minus charge. So there is an ionic bond in ammonium chloride. But within the NH4 plus ion, there's also a covalent, and it's a polar bond. Therefore, a mixed type of bond exists here. Moreover, one of these bonds is formed by a specific mechanism that we call donor-acceptor. Let me give you another example. Let's say if this were sodium sulfate. Sodium 2 sulfate. Let's give another example. Let's say, for example, if this were sodium 2 sulfate. What kind of chemical bond? Let's analyze it. Sodium is a metal. Sulfur and oxygen are not metals. Of course, there is an ionic bond here. But in addition to that, if you build this formula, and we will build such formulas, there's also a covalent bond between the sulfur and the oxygen. And it's a polar bond. Polar. But the most difficult are the examples of organic chemistry. Here's an example. Ethyl alcohol, ethyl 5 oxygen hydrogen. What kind of bonding exists here? From what we have, everything here is not metal. So the bonding here will certainly be covalent, but what kind of covalent bond is there? Well, firstly, the way the ethyl alcohol molecule works is that there's a carbon, and in organic chemistry, carbon to carbon is always a covalent bond. It's going to be covalent, it's not polar. Beyond that, that bond will be, let me clarify again, between carbon, then carbon hydrogen, carbon oxygen, and oxygen hydrogen that will also be covalent. But this bond will be polar, and it's going to be, again, carbon hydrogen, carbon oxygen, and oxygen hydrogen. But in addition to that, there will also be a hydrogen bond between the ethyl alcohol molecules, because there are exactly the sort of elements that form it. It will be a bond arising between actually the ends of this group, between the OH. So the hydrocarbon radical will be a kind of offshoot, and the OH groups will be connected to each other by an intermolecular hydrogen bond. So it is not always a question of which chemical bond is unambiguous. Of course, if these are simple examples, then explaining what kind of bonding is not a difficult question. But judging from my examples, it's not always easy to determine right away, and you have to look a little deeper. Plus, we will find out from chemical bonds how such molecules are formed and how their formulas are constructed. To do that, we'll devote a few lessons to it, how covalent compounds, ionic compounds, and how the chemical and physical properties of these substances are formed based on their chemical bonding. I hope you understand how we solve the problem. Goodbye.